Now you can make your own practice test, but here's one that I will be doing, which will be a Unit 1, which covers chapters 1 and 2. Now in doing a practice test, what you want to do is to take a moment, have some paper handy, carefully read the example, and write it out. And that's what we'll do for this first one. 3x minus 5 is greater than a negative x plus 3. And to do this, we'll use the whiteboard. Now, this is an inequality, so there's going to be a whole range of answers. And they're solved in a similar way to an equation. So let's just imagine that this was equal to each other. And your basic protocol for solving this is to get all the letters, the variables, over to one side, all of the numbers over to the other side. So we can use the transposition technique where we're going to take this negative x from this side, move it to the other side where it becomes a positive x, so we're left on this side with a 4x. That is, add 1 here, 1x, add 1x. Now to get rid of the negative 5, or to move it to the other side, we're going to transpose it, and when we do so, it just changes signs on the other side. So on this side a negative 5, on that side a positive 5, so we're going to get 8. Now we solve that as if it were an equation, but there's actually an inequality symbol there. Now, the one difference between solving an equation and an inequality is if we had to divide by a negative here to get rid of the 4, or to make this a 1x, then we'd have to reverse that inequality sign. But since we're going to divide by a positive 4, the inequality sign stays the same. So here this just becomes a 1x, that we don't write the 1, and is greater than 2. And again, you have to be careful of the signs, and if you're ever dividing or multiplying at this stage by a negative, then you have to reverse the sign to keep the statement true. Now, they're asking us a couple of things here. If we were to graph that, the number we'd be interested in would be the 2. And then what sign would we put on the number line? Well, for just an inequality sign, we're going to use a parenthesis. And since its x is greater than 2, the parenthesis will face to the right. And this indicates that all the values here, going up to positive infinity, are in the set of solution. And we would write this in interval notation as our 2 is not included in the set. That's what the parenthesis indicates. And this goes to positive infinity out in this direction. Now, when you put this in the math lab, they're going to give you a choice of parentheses, a bracket and a parenthesis and a bracket, or 2 brackets. And you're going to choose for this one the 2 parentheses, and then you move it to a 2, then move the other one to infinity, and then what will appear here is the ellipsis. Okay, that's this first one, and let's take a look at the answer now. And there it is, from 2 with a parenthesis to positive infinity. Now, the second part of this question is they will be asking you to graph it. Again, selecting the 2 parentheses, moving it to the 2, and then moving it to positive infinity. Remember, infinity always has a parenthesis. Now, this next one is pretty straightforward. All you're asked to do is plot these on a number line. So it's taking your mouse and moving the points to various places or clicking on the appropriate spots. Let's go on. For number 3, we're asked, is this a perfect square? Well, 10 times 10 is 100, but 2 times 100 is not a perfect square, which would be 200. So the answer is no. And if you were to put 200 into your calculator, you'd see you wouldn't get a whole number. So as we look at example 4, we have a word problem. So pause, read it carefully. Cummings are moving across country. Mr. Cummings leaves 4 hours before his wife. If he averages 70 miles per hour and the wife averages 95 miles per hour, wow, she must be flying here. How many hours would it take Mrs. Cummings to catch up to Mr. Cummings? So here, a diagram might be helpful. Now, we know they're going to leave from the same place, and they're going to meet up at this time. Now, we know one of the rates, and we're going to use the formula distance equals rate times time from our toolkit of formulas to help us. And this is going to be 70 miles per hour. And the wife is 95 miles per hour. Now, we have the rate. What we don't have is the time. But they're telling us in the problem that one time is going to be t here. This is for the husband. Now, how would I indicate the wife's time if she's going to leave 4 hours later? How much less time will she have if t is the amount of time the husband has? Well, would you go along with t minus 4? So again, we don't know the husband's time, but we know the wife's time is 4 hours less than that. So putting it in parentheses. And we know that rate times time is distance. And this rate times time is distance, and this distance equals each other. So our formula then will be 70t equals 95t minus 4. And you have to put this time in parentheses because this is a single unit, and putting it in parentheses gives it that quality. All right, I'll take a moment to work this out. Okay, let's go to the whiteboard again and check this out. So there's a couple of ways to solve this. What I decided I would do is bring the 70t over to this side. That is, transpose it or subtract 70t from both sides, and I got 25t. Then I'm going to just transpose the negative 380 to the other side where I got a positive 380. And then I divided both sides by 25 here. And I get t equals 15.2. Now, some of you may say, let's put that as the answer. And then let's check this out to see what's going to happen as I go back to the regular board. So we got 15.2. And let's just get rid of this for a moment. And you say, oh, the answer is 11.2. And that would be an error if you put in there 15.2. because they're saying, how many hours will it take the wife to catch up? Now, 15.2 was the time it took the husband to get to that point. So in order to get the answer for the wife, remember the wife's time is 4 hours less than that. So that have to be critical. Now, if I saw that you had 15.2 as an answer, of course, this program, the software, would count it wrong. But I know you had gotten all this formula correct. You just forgot to answer the question that they're asking. All right, let's go on. Now, in this example, let's read it carefully. You're translating English into an algebraic expression. And you're using, and you have to use this letter X to represent the costs of a jersey. Okay, you want to represent the cost of purchasing a football helmet and a jersey if the helmet costs $2 less than quite twice the cost of the jersey. So what did we say the jersey costs? Well, they're saying the jersey costs X. Now, what's the cost of the helmet compared to this X? Well, it will be twice the cost of the jersey. That would be 2X. And then $2 less than that. So without simplification, this is what they were looking for. Now, this person only put the cost of the helmet and forgot to put the X in, but they received partial credit from me because they had part of it done. They just didn't include the whole thing. So part of this is being able to answer the specific question they're asking. All right, let's go on. Now, for this one, they're looking for solving an equation after you've read this. So we're going to write it out. Negative 5y minus 6 equals a negative 2y. So this is a basic equation. We'll go to our whiteboard. So again, we want to put everything over to one side, and I mentioned try to keep the equal signs underneath one another. There are no fractions. We don't have to combine like terms. We're just going to do some transposing. So we're going to take this negative 5y, move it to the other side where it becomes a positive 5y. So we end up here with a positive 3y. And that's negative 6. So we've done it. Now I like to try to keep my variables positive. So when I divide, I don't have to worry about signs. I'm going to divide this by a 3, divide this by a 3. I get y equals negative 2. Hopefully something a little easy here. Let's go to our whiteboard, and y equals negative 2. This one is rather straightforward. If you were to draw a number line, negative 1 is there, and negative 5 is there. So anything to the right on a number line is larger than anything to the left. So the symbol we're going to use here is negative 1 is greater than negative 5, and that is correct. In this example, read the question carefully. Here we have an isosceles triangle. Well, in an isosceles triangle, two sides are the same length. So this side and this side are the same length. And it's placed on top of a square. Well, here's the square. So the sides of the square are 27, 27, 27. Now they're asking us for the perimeter of this. So how would you figure that perimeter out? Well, you would be adding this, 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 and this, and not this side. This side is not included in the perimeter, and the answer is 123. Again, you're looking to read it carefully, understand what they're stating. Keep in mind, when you take a test, you must show detailed work and then submit that. Once you submit your tests, attach it to an email and send it to me. But there are some shortcuts I will accept. Like for this next one, they want you to work this equation. And the first thing we have to do here is there's no fractions, so we're going to get rid of parentheses. So you can do it this way. So 3 times 7x is 21x. 7 times 4 is 28. So you can get rid of the parentheses. You don't have to write this stage down here. And then 9 times x is 9x. 9 times 3 is 27. And then plus 11. So let's go to our whiteboard. And we want to combine like terms. So we get 21x plus 28 equals 9x, and this will be 38. Now what we want to do is get all the variables over to one side. So I'm going to transpose the 9. On this side it becomes a negative 9. So this gives me 12x. And I'm now going to subtract or transpose the 28 to both sides, and this will give me a 10. So now I'm going to divide both sides by the coefficient of the variable, both sides. So I end up with a 1x. I don't write the 1. And I'm asked to simplify that, and this gives me 5, 6. So not too bad, but this is the work I would expect to support your answer. All right, let's go back. And there is our answer. X is 5, 6. You have to know how to put a fraction in there. Now, for this one, a little tedious, but show the work carefully. And here a person has a checking account, so it has this balance, starting with. During the month, he makes deposits of this, 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 and this. And then he writes checks of, let's change colors. So this is a negative, this will be a negative, this will be a negative, this will be a negative. So what I would do is I'd add up all the reds. These are all the positive. Add up all the blues, and then have your negatives. Let's go back to our red. I didn't get the red yet. Let's see here. There's the red. Subtract your total of the negatives from the positives. And you got to be careful. Double check your work, because just being off by 10 cents makes it incorrect. And there's your end balance. So a little addition, subtraction, which are positive, which are negative. Here they're looking for a strategy to solve for a particular variable, y. So let's write it out here. 5x plus 4y equals 9. Going to our whiteboard, we want to solve for y. Well, our y is already on the left, so let's transpose the 5x. So this will be 4y. On this side, this becomes a negative 5x. That's a nice part of transposition. And then a plus 9. Now, to isolate the y, I have to get rid of the coefficient, which is 4, so I'll divide this by 4. And a good way to do this is divide each of the terms by 4. Although it should accept it all over 4. This way is going to be one that we use in our next chapter, chapter 3. And then this will become a positive y here, equals a negative 5/4 x plus 9/4. Let's see what they have here now. And that works out very well. They put it reversed. I guess they would accept it either way. And again, anything that you get wrong, I check, looking carefully at your work to see if I can give partial credit. Now, in this example, they're checking your skill at organizing data. Here, a person went shopping, bought 3 pairs of shorts, so 3 times 19 is going to equal something. 5 tank tops, 5 times the cost of each tank top is 30. And 1 pair of sandals, following the protocol, and 2 bathing suits. So this is going to give you, let's see, this is 57, this is 150, this is 37, and this is 80. Now when you add them up, it should add up to this. And I checked it with my calculator. But again, what we're showing you is the kind of example and then a protocol for showing the work that almost ensures that you're going to get it correct. You're going to be able to use your calculator. All right, here we have another equation to solve, but this one has fractions. So let's write it out. And go to our whiteboard. Now here, we could get rid of, in fact, let's do it that way. I'll show you both ways. We had said, whenever you have an equation with fractions, you multiply through by the lowest common denominator each term. Now remember, there's an unwritten 1 there, so there are 3 terms. And our lowest common denominator here is 3. So multiplying each term by 3, this becomes 1. This becomes 3y. And then this becomes a negative 2. The 3's cancel out there. Now I bring my negative 2 over to this side as a 3. And I get 3y. Divide both sides by 3, I get y equals 1. Now that's one way to do it. The other way to do it is just transpose this to the other side, where it would become 1/3 plus 2/3, which equals 3/3. And 3/3 is a 1. So sometimes it's a flip of a coin as to which way you're going to do it. All right, let's go back and clear this, and we see our answer is y equals 1. All right, in item 14, and I would make a little sketch of that on my paper. First of all, they want us to choose a formula that represents the area of a trapezoid. While reviewing them, this is interest formula, temperature formula, perimeter of a square, perimeter of a rectangle. This would be the formula for an area of a rectangle or a parallelogram, perimeter of a triangle, circumference of a circle. Way at the bottom here. There's the formula for a trapezoid. So let's write that over here. A equals 1/2 H times B plus C. Okay. Now, one of the things they often ask us is, without substitution, we want to find the height of this trapezoid. So, in a sense, that would be solving for the letter H. Now, this is an equation that has fractions. So what would be the first thing you'd do? Get rid of the fractions. So this is one term on this side, and because of multiplication in parentheses, this is all one term. So we're going to multiply each side here by 2, our common denominator. So this will become a 2. Multiply this fraction, which is one term, by 2. This just cancels out. So now I can use my eraser to get rid of that. Now I want to find out what the letter H is. So I go and divide this term here, or this factor, this portion, which is B plus C. If I do this side, I have to do this side too. B plus C. I could put it in parentheses or not. So now this, anything divided by itself is 1, becomes a 1, as long as it's not 0. And I get then H equals 2A over B plus C. Okay. Now, they're telling us that was the thing that we had to pick out the correct formula here. Now, I moved to the next part of this question. What is the height? Well, in the previous one, we didn't know the area, but now we do. It's 72 inches. So 2 times 72 is 144. And then we have to add our 4 and 8 together. 4 and 8 is 12. So now we get our height is 12. And that's what they're getting here. I've kept the work from a previous slide. But again, this is often how they ask this question. Pick out the formula, solve the formula for a particular letter using the techniques we've had in our lessons, and then do the substitution to solve for the unknown, which is what we've done here. Now, example 15 asks us to combine like terms. So you might say, what would be the protocol for that? Well, I had mentioned you can put them all in like term columns. I'm putting all the y squares in one column. So I have this one and this one. Now I have here a negative 4x and a positive 5x. And then here I have a 1 and a 2. So I now have them all in like term columns. So I add this up. I get a negative 8y squared. Remember, when you're adding or subtracting like terms, the variable part never changes. So here this would become a 1x, and then this would become a 3. Now, you have to be careful with something like this. Now, when you're doing calculations and you put a 1x there, that's okay. But when you put it as an answer, they want you to simplify. By convention, if something is a 1x, we never write the 1. Now, this person did that. They took off points because they didn't simplify. They want just the x. Now, the order listed is not significant. They will accept it this way or this way, but you can't have the 1 in front of the x. They'll take off for that. Now, for something like this, they're checking order of operations, and that would be, please excuse my dear Aunt Sally, where you have parentheses and exponents, whichever come first from left to right, you do those. Then you do multiplication division, whichever comes first from left to right. And then finally you do addition subtraction from left to right, whichever comes first. So let's write this out and see what we need to do here. -3 times 2 plus -10 divided by -2. We'll go to the whiteboard here. So here we have multiplication first, and this will be a -6 plus. Now we have division. Well, a -10 divided by -2 is a +5. Well, we don't need to have that extra addition symbol here. So now, just summarizing, we end up with a -1. Now, what if it's a -1 all by itself, no letter? We write the 1. I know that may be a little confusing here, but that's what we do. Let's check out our answer, and the answer is -1. Now, in a word problem like this, in any word problem, you need to read it carefully. So Megan owes this much for text messaging. If her plan costs $15 for the first 300 messages, and then 15 cents for each additional text message, how many messages did she send that month? Well, we're going to do some figuring over here. Well, we have 37, 35, and we'll have to subtract the $15 from that. So if we subtract $15 from that, and remember that's for 300 messages, we get here $22.35. Now, each additional message costs 15 cents, so we're going to divide this by 15 cents. So let's do that. So that's 149 messages. Now, I've had students, when they did this, they would put 149 as the answer. But that's not the statement they're asking us to answer here. They're asking how many messages were sent that month. So you have to add this and this together to get 449 messages. Now, you're going to get maybe a similar question to this. What we're showing you here is the protocol and the kind of work I'm looking to see in order to get the answer. Now, here's an inequality that's already solved. This is the arithmetic notation of it. They just want us to graph it. So noticing the inequality sign, greater than or equal to, which of these sets of symbols do we want to use? Well, ideally, put it on a number line first. You're going to be interested in the 5. Now, because it's also equal to and greater than or equal to, you're going to use what symbol here? Well, you're going to use a bracket. And then that goes off in this positive direction to positive infinity. So in interval notation, this would be, and I'm not following my own protocol here, this would be a bracket right from our graph, 5, comma, positive infinity. And we said infinity always has a parenthesis. So you would select then the bracket and parenthesis, this one. It then goes to the graph, and you move the arrow to 5 and take the arrow to the end of the line where the ellipsis forms. And there is the correct answer. Now, here, this is just pretty straightforward because they give it to you in the algebraic notation. This is interval notation, and then this is the graph. And a second part of this is, what type of interval does this show? Well, if it were both parentheses, it would be open interval. If we have one where there's a bracket, we say half open interval. Okay? If it were two brackets, it would say closed interval. Again, this is sort of a vocabulary check. Let's go on. Again, your test will have perhaps similar things. These are just randomly taken from the material that was covered in our lessons. Here we're asked to write English into an algebraic expression. And we're asked to use either X or Y to describe unknowns. The sum of two numbers times 4. Well, how do we express these two numbers, and especially as a sum? Well, you'd have to put them in a parenthesis. So that would be X plus Y. This then expresses the sum of these two variables. And you're going to multiply that by 4. So you put the 4 out in front. And that is correct. All right, let's go on. A few easy ones now toward the end. The opposite of a negative is a positive. The opposite of a negative is a positive. And we want to evaluate, and again, a protocol for doing this is to 5, and then parenthesis. What is your X value? A negative 3. Minus 2. What is your Y value? A negative 7. And then a negative 1. So here, this is a negative 15. This is a positive 14, negative times negative, and a negative 1. So this is a negative 16, combining all your negatives. A positive 14 will end up with a negative 2. Let's see how it works out. Perfect. For our last example, I know this ran a little long, but we did hopefully review lots of stuff. Write it out. And we'll go to the whiteboard. So here we are collecting like terms. So this just becomes a 1n. Now you could write it the 1 while you're doing calculations. That's okay. But remember, we don't write 1 in our answers if it's just one n. So minus 6 equals a negative 17. So n now, transpose the negative 6 to this side, becomes a positive 6, and a negative 17 is a negative 11. And then going back, there is our answer, and this winds up our practice test. And again, bring questions to class, ask our tutors. You want to be sure you are knowledgeable about the protocol and the work needed to support your answers. And good luck on your test.